Hello, everyone, and welcome to another session of Ask Tom on JSON. Today, we will talk about the new JSON type feature in 20 and especially what it means if you work with Java and JDBC. We already had two sessions on JSON type. One was on the internals of JSON type and why it gives you great query and update performance. We had a second session where I introduced JSON transform. That's our new piecewise modify operator. And today I have Josh Spiegel here. He's a colleague of mine. He works in the same team. And he will introduce us to what's possible and best practices with Java, JDBC, and the new JSON type. If you have any questions, please put them in the chat or in the Q&A. I will monitor this. And with that, I give the mic to Josh.
Thanks, Veda. So the things that I'm going to talk about and present today are part of the 20 preview release. And it's possible that by the time it actually releases, things may have changed. So please don't hold us to anything that you hear or see today. So we're mainly going to focus today on the new Java API for JSON type and JDBC. But before I go into that, I've got just a few slides where we're going to give an overview of JSON type in 20C.
So new in Oracle 20C, we have a new built-in SQL type called JSON. And the basic idea is that you can create tables with columns of this type. You can put your JSON data in there. You can get it, put it, query it, update it. That's kind of the basic idea. And so like this example that we have here on the right, it's creating a table called emp is for employee. Kind of use this throughout the slides. It has a column named data, and it's of type JSON. This is followed by an insert statement where it inserts a JSON object into this table with two key value pairs. Name is Smith and job programmer. And then it does a select statement over this data. And so you're able to query this JSON data in ways that kind of are similar to how you would query more traditional relational data with SQL. And so we're going to focus mainly today on how you would access these JSON type values from a Java program. But before we get into that, there's a couple things I want to go over to kind of set the context for what we're going to talk about in JDBC. So the first one is the data model. JSON, let me minimize this video. JSON has a fairly minimal set of types in standard JSON. It has objects, arrays, strings, numbers, true, false, and null. But for JSON type, we have all of these, but we've added the SQL primitives as well, binary, float, double, timestamp, date, intervals, and raw. And this is kind of similar to what other NoSQL JSON document stores have done. They have their own JSON-like data models and their own sets of extended SQL types, or I'm sorry, extended primitive types. And the reason why we do this is one, they're kind of useful in their own right. You know, for example, it's useful to be able to say this attribute is a timestamp instead of a string. But in our case, it's also useful because it gives us fidelity with relational data. And what I mean by that is that you can take a table row, create it, and convert it to a JSON object, and convert that JSON object back to a row. And you can do those types of conversions without losing any information. In the example here on the right, we've got a kind of normal-looking relational table with a number column, a timestamp column, and a varchar. And in 20C, we have this JSON constructor expression, which automatically converts rows into JSON. And so if you imagine converting an order row into a JSON object, that can be done without losing information, without having to convert the timestamp to a string. The other reason or item I wanted to talk about is performance. One of the reasons we wanted to add JSON type is for performance reasons. So these JSON type values are stored and transmitted across the network in our binary JSON format. We refer to this binary JSON format as Oson. And there's three important aspects of this binary format. The first is that it's an indexed format and it supports efficient random access. And so what this means is if you're looking at an Oson value and you're pointing to a particular value within that document, you can move around to the other values you can move around efficiently, and you can move around without converting that value to like other in-memory structures such as hash tables or arrays. The other important aspect is that it's self-contained. A lot of these other binary JSON-like formats out there require defining a schema up front in order to encode and decode the data. Oson isn't like that. It's more like JSON in that it's completely self-contained, self-describing. You can encode it or decode it without an explicit schema. And then finally, the other thing to know about it is that it does dictionary key encoding. So if you have a JSON value or an Oson value with lots of keys that maybe the same key is used multiple times across various objects, those key strings are encoded once in the header of the value, and then they are referenced using unique integers throughout the document. And so this allows it to compress a bit in some cases, and it also allows us to process that value more efficiently, since these integer codes are easier to compare than strings are. And so this aspects of Oson helps us with performance for inserts and gets. You can insert and get more efficiently. It helps us for doing query evaluation over these values, and it also helps us for updates, because we can, if you're modifying a medium to large size document and you're only making a small change to that document, with Oson we can make an update that's proportional to the size of the data that you're changing, instead of making a modified copy and writing that thing as a whole. Okay, so this slide depicts an example. We have a JSON object for a programmer named Smith. The name is Smith, the job is programmer, and the Smith makes $40,000. And so this is depicting the database on the left here, and how this might be represented as Oson stored in the database. And above it, we have a SQL expression that accesses the name attribute of this JSON object. So if the database has to evaluate this expression, what it can do is it can use the index jump offsets to jump directly to the value it's looking for without looking at the job or salary attributes of this programmer. But the thing that for today that I want everybody to be aware of is that when a Java application selects this JSON document, the document is sent across the wire as is, as it's stored to the application. And then if that Java application has a reference to this object, and it says get string of name, tries to get the name value of the programmer, the JDBC internally does the same trick. It's able to jump to the name of this programmer without touching the job or the salary. So as we're seeing examples and we're going through JDBC, I want everybody to be aware of that this is what's going on underneath the covers. I'm just going to be a minute on this slide. It's kind of an elevator pitch type slide. The rest of the talk will be technical. But I just wanted to say that Oracle Database is an excellent choice for operational JSON storage. These other NoSQL document stores that store JSON, several of them advertise that they can support single-digit latency at scale, meaning that for small reads and writes of JSON, they can keep the response time under 10 milliseconds. And Oracle Database, we can do that too with JSON type. But we're able to do it without sacrificing things like transactions, durable writes, or snapshot isolation, all things which are sometimes overlooked but important to have, robust, stable applications. We're scalable. We support sharding. We support rack. Gartner calls us the leading translytic database, which means that we're capable of handling both analytic and transactional workloads at once. And we've brought that underlying technology to bear on JSON type values as well. We're multi-model. You can store XML, geospatial, graph, regular relational data all in one database alongside your JSON. And the one thing that is I think often overlooked is that JDBC has been around a long time, and so it's compatible with a lot of old existing tools that you might be using for analytics. So you can use these new JSON features to get this modern application development, but at the same time you can create live relational views over this data and expose it to these older programs that won't even know that they're accessing JSON data. Okay, so on to JDBC. So we're going to talk about today the Java API for JSON processing in JDBC. And so what is this thing? It's facilities to read, write, and modify JSON type values from a Java program. The specific features include a mutable tree or object model, an event-based parser and generator. It provides access to these extended types I mentioned, timestamp dates, and so on. It supports both JSON text and this Oson binary format, and it has optional integration with JSONP or javax.json. Where do you get it? It's in the core JDBC jars, so it's either in OJDBC 8 or OJDBC 11.jar. Normally, you would get these jars from either OTN or Maven Central, but in the preview release period, the only place you can get it is in the database installation. So I'll have more instructions on how to do that when we get to the demo. And within these jars, there's a new package named oracle.sql.json. So oracle.sql.json has a bunch of interfaces in the package. They're all in the Java docs, but all of these different classes and interfaces in this package mainly fall into three different categories. The first category is interfaces for working with JSON in a tree data structure, or in a tree model. The other is for working with JSON in an event model, a sequence of events representing a JSON value. And the third is the factory. The factory is the starting point for creating instances of these data models. So let's look at the factory next. The factory is a single class, and it has a whole bunch of methods. But now all these methods fall into another three categories. So there's methods for reading and writing binary JSON. There's methods for reading and writing JSON text. And then there's methods for creating an instance of JSON that's not from Oson or text, but maybe you want to just create a new instance programmatically. You can create those values from this factory. Okay, so first we're going to look at some of the details of this tree model. So some people call this the object model or DOM, but object in this context has like three different meanings. So I'm using the word tree instead. So basically the idea is that you're representing the JSON value as a tree data structure, and all the different values within the JSON, the objects, the arrays, the strings, and so on, are represented as nodes in the tree. And from your program, if you have a reference to one of these object nodes, you can use methods to kind of navigate around the tree in any order that you wish. So here we've got a JSON value for a programmer named Smith. He's got a created attribute and a phone attribute with an array containing 2 strings. And this kind of depicts how that would be represented in a tree data structure. So here's a quick little example to give you a flavor. You new up a new factory, then you can create an object, and here it's putting attributes, key value pairs into this object. Then it's printing out, it gets back this name, and then it converts the object to string, and it prints them out. And if you ran these lines of code, you would see something like below. It would print out the name Smith, and it would print out the object as a JSON text. These are the interfaces for the different types. So basically, we've got a different interface for all the different objects, arrays, and primitive values that you can have in JSON. All of them implement this interface called Oracle JSON value. And you can access them as JSON value. And if you aren't sure what the type of a value is, they all have an associated enum type code associated with it. So you can introspect the type using this enum. And we'll see what this means a little bit more in the demo. This column here shows the corresponding SQL type in the database for these different primitive values. And then the final column shows, like, if you were to take one of these values and serialize it to a JSON text, the corresponding JSON type. So like timestamps and dates get, if you convert to JSON text, they get serialized as strings. This next slide shows the type hierarchy of these tree interfaces. So again, everything's a JSON value. And so when an arrow points in this diagram, it means extends their interfaces. So it's an interface extending another interface. So a lot of these primitive values interfaces just extend JSON value directly. For numbers, we have kind of the intermediate interface that you can work with to access the value if you don't care about the different number types. Then we've got an object and array interface, and there's another intermediate structure interface for objects and arrays. And then they both implement the Java collections API. So an object is a map, and an array is a list. So you can work with these as Java collections if you'd like to. Now, one important thing to know about the tree model is, so let me check the chat here. Is that objects and arrays can either be mutable or non-mutable, meaning sometimes you can change them, you can modify them, and sometimes you can't. And the basic idea is that if they're doing this in-place read of this underlying binary data, you can't modify them. But if they're backed by like in-memory data structures, like hash tables and things, then we let you modify them. And so this table here gives the 5 places that objects and arrays can come from, and it tells you whether they're modifiable or not. So if it comes from the database, which I'll explain how that works in a second, it's backed by the binary that's was stored in the database. So yes, it's read-only. You can't modify the values coming back from the database. If you create it directly from an Oson source, maybe a file or a cache or something, then it's also backed by Oson, so you can't modify it. If you bring it in from a JSON text value, then you can modify it. If you knew it up programmatically, then you can modify it. And then we also have these copy methods. So if you got one of these values from the database or something and you wanted to make changes to it, you can make a copy of it, and then that copy you would be able to modify. So that's the tree model. The next thing I wanted to talk about is the event model. So the event model, you're representing a JSON value as a series of events that come in one order. And so you have to take these events as they come. And so you have events like start object, you have events for keys, you have events for primitive values, you have events for arrays. So here's an example of a JSON object for this same guy, Smith. And these boxes kind of depict the events that would be for this object. So we'd have an event for the start object. We'd have an event for the name, the key name. We'd have an event for the string Smith, and so on. And so there's only 2 interfaces related to these events. One is JSON parser. And so that produces a sequence of these events. And so you get this event stream by calling next, next, next on the parser. And these events can come from either Oson or text. And then we have the generator, which is the reverse of this. So you're producing a sequence of events and sending them somewhere. And you call these write methods on the generator to send the events out. And these events can be, the generator can be sending the events to either a JSON text or an Oson. So here's an example with JSON generator. It's creating a factory, it's creating a new file stream, and it's creating a new generator that's going to write to that file stream. So it's a binary generating, meaning it's going to be generating Oson into this file. So it sends a start object event, then it sends a key and a value event. The generator has these methods that are kind of convenient for writing 2 events at once. So here it's writing 2 events, the name and the value, the key and the value rather. And then you write the end object, and then you close the generator. And at the end of this file would contain some binary JSON. Here's an example of the parser. So here we're reading in that file, and we're creating a JSON parser. And so as we call next, next, next on this parser, it's going to be iterating and based on this switch, processing these different events. So if we ran this, we would see output like shown on the right. We'd see print out for all the different events that make up this value. Okay, so those are the 2, what we talked about are the 2 models, the 2 different ways we have of representing JSON in JDBC. And so next, but we haven't really talked about SQL yet, or the database. This has all kind of been kind of independent. So next we're going to talk about how you can have these 2 different models interact with the database. So SQL statements can take JSON as input and they can produce JSON as output. And we did this without adding any new interface methods outside of this new package, Oracle SQL JSON. And the way that we did it is that we rely on these getObject and setObject methods that are already there and that have been there for a while throughout JDBC. So this slide is about how you get JSON from the database. There's two methods in JDBC that are capable of returning JSON values. There's actually variants of these, but it's basically these two methods. There's getObject on result set and getObject on callable statement. And these methods take two arguments. The first argument is that you're identifying the column of the value that you want to get back as JSON. And the second argument is that you're telling it the Java type or the Java class that you want to consume that value as. And then this table here to the right is basically showing you the different Java types that can go into the second argument, the different ways we support of exposing JSON. So in this first row, you can either specify a string, a reader, or an input stream. And if you do that as the second argument, what you're going to get back is a JSON text. The next one is the tree model, so Oracle JSON value or any instance derived from that, like Oracle JSON object. If you specify this, you'll get the in-place tree model representation of your JSON value. There's also Java XJSON, which I'm going to talk about next. This is the quote-unquote standard interface for JSON values in Java. Then you can also specify parser to get the value as an event model. There's this last thing, Oracle JSON datum, which is something we introduced that just allows you to tell it, hey, I want to get the raw Oson bytes back directly from this call. And this is useful if you want to stick the Oson into a cache or a file or some other place where you're going to read it and process it later. And so here's an example at the bottom. So I'm executing a select statement, select this JSON column from the employee table, and then I call result set.getObject and I tell it, hey, I want to get this JSON value back as a Oracle JSON object. And so I get it back, and then I could start calling getters on Smith. Okay, so here's the next slide. It's about how you send JSON to the database, like if you want to do an insert or an update or something. So for this, we use the methods shown here. Now there's 4 different main methods. There's setObject on prepared statement, there's updateObject on result set, and there's setObject on callable statement, and then there's setObject on row set. So all these different methods take 3 arguments. The first argument is identifying the bind variable that you want to send the JSON to, the bind variable in the query. The second argument is the JSON value that you're setting. And the third argument is you're telling it the SQL type. And in our case for JSON, the SQL type is always going to be oracle type.json. Now, these methods will actually let you skip specifying the SQL type and everything will work. But the best practice is to make sure you put that third argument in there. And the reason is that, like, for example, if you send it a text value here, really what you want to happen is you want that to be encoded as binary JSON before it's sent to the server. And if you don't tell JDBC what the SQL type is, it won't know, because we don't do any extra round trips if we don't have to. So it's like, well, I'm inserting this value, this string, but I don't really know what's going to happen to it on the other side. So I'm just going to send it as it is to the server, and the server will be perfectly happy to take that value and encode it to Oson for you. But it's better for performance if you let the JDBC driver do that encoding, because it may be able to compress it and you'll save on the network and transfer costs. This is showing here the different types of values that you can pass into the second argument. So you can pass in a string, a JSON text as a string, or a reader, or you can pass in a sequence of bytes, either an input stream or a byte array. And these byte arrays and input streams can either be a UTF-8 encoded JSON, or it can be an Oson, a raw Oson value. And the driver is able to sniff that out and distinguish which it is and do the right thing. So if you give it UTF-8 in bytes, it will encode that as Oson and send it on its way. If you give it Oson directly, it will take that Oson and send it right on without doing any conversion. You can give it the tree model instances, you can give it the event stream instances, and you can give it this Oracle JSON data. Here, I think we did this for symmetry with the reads, but it's maybe kind of has limited use because you can wrap it in Oracle JSON data, but in this case, you can also just put it in a byte array, and that's both ways work for sending Oson to the server. Okay, so at this point, before I continue with the rest of my slides, I'd like to do a demo for a while. So the demo that I'm about to show is uploaded to our demo repository on GitHub. And so there's a link to this in the end of the presentation. So everything I'm about to show you and do is you can go run these yourself. And there's instructions here on how to do that. My understanding is the only way to get the 20.3 preview release right now is to install it in our cloud compute instances. And beta has a very nice step-by-step instructions on how to do that. In the interest of time, I'm not going to do that. I've already gone through the steps and I have the database running in our cloud. So I'm going to skip step 1 and I'm going to go on to step 2. And I'm going to clone our example repository. Okay.
Josh, can you please increase the font size? It will be easier to read in the video. Thanks a lot. Great. Thank you.
Is that better? Okay, so the first thing I'm going to do is clone this GitHub repository. It's usually pretty quick. A little slower today. We had a storm last night that took out the internet for a while. Okay, so that's it. So now we have this directory with the examples in it. And the next thing I'm going to do is set this environment variable URL, which has the connection string to my database. Now this, I'm just showing this one for an example. I changed the password and the IP just in case there was somebody that thought they were funny and wanted to delete data while I'm doing the demo. But I'm going to source the real value here. So now I've got this variable URL. And I'm going to go into JSON and DB. So now I've already installed Java and Maven. And so now I'm on to step 4, where they want to download this JDBC HR and put it in your local Maven repository. I've also already done that. So now I'm going to build the examples. So Maven package. Okay, and then there's an example here to how to run the example. And there's a list of examples here that I'm going to run for the demo. I've got this little shell script here that basically simplifies. Basically, it takes the example class you want to run and this URL connection string. So I'm going to run the first one. I'm going to run, here's the URL to my database, and I'm going to run the create table example. So let's look at that first. So here, I'm going to try to increase the font here. Okay, so here it's basically getting a connection to my cloud database. And then it's creating a statement. And then it's creating a table, the same one you saw on the slides, named emp, with a single column data of type JSON. And then it prints out that it created the table. Oops, looks like I didn't drop it from last time. There we go. So we've got a fresh empty table named emp. Okay, let's go to the next one. Here's insert. So we've got this table now, and we're going to insert 3 employees into this table. So the first thing we do is get a connection. Now we've got a prepared statement where we're inserting into emp, and we've got a bind variable :1. And the first employee that we're going to insert is Blake. His job is an intern, and he makes $20,000. And so we're inserting Blake as just a regular Java string. And so we call this set object method that we saw on the slides. We say that we want to set this JSON to the first bind variable, in this case, the only bind variable. And we're telling it this is going to a JSON type column. And then we say execute. And after this line, Blake would be inserted into the database. The second one that we're going to insert, we're inserting another employee here, but we're doing it using the tree model. So we create a new factory, we create a new object, we put in the name. In this case, it's Smith. Smith is a programmer. Smith makes $40,000, but now we're also giving Smith a timestamp of when this record was created. And Blake doesn't have this timestamp, but it's JSON, so that's okay. They can all have different types, different sets of attributes, anything goes. And then we again call set object the same way we did before, execute. After this line, at line 43, Blake or Smith would also be inserted. And then finally, for the third one, we're going to insert a JSON text from a byte stream. So here we're inserting a file input stream from a file named Miller. Again, just piping it into set object and then executing. And after this, Miller would be inserted. And so here's Miller. So Miller is also a programmer. Miller makes $50,000, and she has an email address. So now she has an email address where Blake and Smith do not. Okay, so now if we run this, it says 3 employees inserted into the table. So let's go make sure that actually happened. So I'm logging into a SQL plus prompt for my database, and I'm just going to do select emp. And there they are. These are the three JSON values in the column data that we just inserted from Java. Okay, so moving on.
So Josh, the result we saw as a string that got, I think, converted directly from the Oson in SQL Plus, correct? The database didn't store this as those strings, correct?
Right. So the SQL Plus is aware of JSON type. So if you select a JSON type value, it, as Beta says, it's converted to a JSON text just so we can read it. But it is internally stored as binary JSON. So moving on to the next example. So now we're going to do get all. So we're basically going to do what we did from SQL Plus, but now we're going to do it from Java. So we get a connection, get a statement. We're executing the query select data from emp, and we're iterating that result set. And at each row, we call get object, and we say, yeah, I know it's underlying it's Oson, that's great, but really I just want a string, so convert it to a string for me. And then it prints out that string. And so this would convert the Oson to a JSON text and print it out. So let's try that. And there they are, same as we saw from SQL Plus. So next one we're going to do is a filter. So again, we're selecting some of these employees from the employee table, but now we've added a where clause, we've added a predicate, and we're saying where the salary attribute in these JSON values as a number is greater than this bind variable value. And we're setting that bind variable value to 30,000. So we're only going to pull back employees that make more than $30,000. And so of those, we iterate the result. And now we're getting back one of these tree model objects instead of a string. And we're calling these getters. It's doing those in-place reads that I talked about. And it's printing out just the name and the job separated by a dash. So let's run this one. So we see we've got Smith, we've got Miller. They're both programmers. It did not pull back Blake because Blake only makes $20,000. So he didn't pass the filter. Okay, so we get a little bit more fancy here with filter 2. So as we saw in this data I inserted, there's no guarantee that all these JSON objects in my table have the same attributes. Or if they do have the same attributes, there's no guarantee that those attributes have the same types. So this filter is an example is kind of highlighting how you can kind of adapt your program to data that might have different attributes or might have different types. So the first thing it's doing is it's selecting all of the JSON rows that have a attribute named created. And if we look back at our data, the only row that has this value is Smith here. So this filter should only pull back one row because there's only one row that has this attribute. So we're using the JSON exists function to do that. So we execute the query, we iterate to the first record and only record, we hope. And here at this line, I'm kind of pretending like I don't know that this value coming back is an object, right? It could be an array, could even be a primitive value. So I'm just getting it back as this tree model interface that all values inherit from, this JSON value interface. And then I'm printing out the type of v1 is, and I get the type of that enum, if you remember from an early slide, that enum that identifies the type of this tree node. And we hope that that's going to say object. Then, so we cast it as to this, we say JSON value.as JSON object, this casts it to an object for us. And then now we're getting this created attribute that we know is there. And again, we're pretending like we don't know that it's a timestamp. And we say the type of v2 is, and we get the enum for that value. And we hope that this prints right here, timestamp. And then it finishes off by just saying, here's the name of the programmer, and it was created, and then the value for the timestamp. So we'll run filter 2. And it works as expected. It says the type of the top level value is an object, the type of this nested created attribute is a timestamp, and then it only pulled back Smith, and Smith is created, and there's the timestamp value. Okay, so the next one I'm going to run shows how to do an update. So in this example, we're going to update the salary of Blake, the intern. So Blake has been doing a good job, so Blake is going to get a raise. So the first thing we do is we select, and we only pull back employees where the name is equal to Blake. So that's only going to pull back one row. And we get Blake back as an object. So we know he's an object, and just print him out. And at this point, this is referencing the binary that was sent across the wire directly, so it's not going to be mutable. And so in order to make we want to do like a modified copy of this and send it back to the server. So it calls factory.createObject and it passes in Blake. And so now we've got, at this point, we're returned a copy that we can call puts on to change it. And so now we say object.put salary, and we change his salary to $25,000. He's getting a $5,000 raise. And now we're doing an update statement. So again, the same predicate, we're going to set where the name is equal to Blake. But now we've got a second bind variable where we're putting in the new object value. And so then we call execute, and this is going to take this modified copy and send it back to be stored by the server. And then it prints out that Blake's salary was updated in the new version. So let's see what that looks like. Okay, so it shows the object before with 20,000, and then it shows the object afterwards with 25,000. Let's do get all again to make sure this really works. If we do get all, see up here, last time we did it, it was 20,000 for the salary. And now it's 25, so it worked. So that's kind of a full document replacement example, how you might do it, like if you're mapping this data to domain objects or something. Okay, so I'm going to stop the demo at this point because we're approaching the end of the hour and I still have a few more slides I'd like to show. But just briefly, there's a couple more update examples. There's one to show how to do an update with JSON merge patch and one to show how to do it with JSON transform. And these examples show you how you can update a value without doing a whole replacement of that value. You can do a partial update. Then there's examples that show how to use Java XJSON and Java XJSON bind. And I'm going to talk about these in the slides I show next, but I probably won't have time to show these examples. But you can come back and run these and look at them yourself. There's another example here that shows how you can convert external data sources into binary JSON. Like this one in particular is using a popular third-party JSON library called Jackson. And it's using the output of Jackson to create a binary JSON value. This example shows how to work with binary JSON directly outside of the database, like creating, I think it creates a file and then reads the file back. This one's just a stub that runs all the example, and this one, as you saw at the beginning, just drops the table. So if you want to restart the demo, you can drop the table. Okay, but back to the slides for now. So the next thing we're going to talk about is JSONP. The P in JSONP stands for processing, and we're not supposed to call it a standard, but I think that's kind of really what it is. But it's the way in Java EE, the set of interfaces in Java EE for parsing and generating JSON. It has a tree model, an event model that's kind of similar to the tree model and event model that I just showed you in Oracle SQL.json. Oracle SQL.json can very loosely be thought of as an extension to JSONP. And in fact, the JSONP JSR is developed by mainly people at Oracle. So those guys still work here, and we consulted them a lot when we were designing Oracle SQL.json. But the question becomes, what's the difference between these two things? So the main differences are given here. So Oracle SQL.json supports these extended types that aren't in standard JSON. So Java XJSON obviously does not. We allow our tree model to be mutable. Java XJSON does not allow a mutable tree model. We're fully aware of the benefits of immutability. We in our group, we work on designing and developing functional languages. We get it, but we also understand that if you're making kind of complex changes to a hierarchical structure, it becomes somewhat hard to do that with builders that make modified copies. So we allow our tree model to be optionally mutable. We support conversion to and from binary JSON. That's specific to the database, so Java XJSON doesn't do that. And we don't support builders or readers like Java XJSON does, and we don't have a services API. The SQL methods that I showed you, the get and set, they're also aware of Java XJSON. So if you have Java XJSON, it does, and it can either be the Java XJSON interfaces that we implement, which I'm about to show you, or it can be from some third-party implementation. The JDBC driver will be fine with consuming those. But this dependency on Java XJSON, because it's in Java EE, it's not part of the core JDK, so you don't have to download this dependency or include this dependency on your class path unless your program explicitly uses it. So for Java XJSON and Oracle SQL.json, you can view these two different sets of interfaces as views or facades over the underlying actual data. We allow you to, at any point, even after the value is created, to kind of move back and forth between these two sets of interfaces. And you can do so without really incurring a performance penalty. They're really kind of lightweight wrappers over it. So for example, if you get back a JavaX JSON object, this still supports the in-place reads and things like that. And so the way this works is all the Oracle SQL JSON interfaces have a method called wrap, and this was documented in our Java docs, that you can be used to move to the corresponding JavaX JSON interface if you need to. And then all the JavaX JSON instances that we implement, that you get from us, they can be cast to Java SQL wrapper, and they can be unwrapped to get to the Oracle SQL version. And so you can map back and forth without actually copying any data. So what's the point? Why did we even do this? So there's several reasons we wanted to support JSONP. It's kind of the standard and people expect it, but your application might already be using it because there's a bunch of people that are already using JavaX JSON. And so if you already have some code that uses JavaX JSON and you just want the database to persist that works. If you're using some application that uses some third-party library that uses it, that implements those interfaces, we'll consume those, no problem. If you don't care about the extended types and you want to keep your application independent of the database-specific APIs, you can do that. Right? You can say, I'm just going to use JavaX JSON. I'm going to stick to standard JSON types and not depend on any Oracle SQL stuff. And then what I'm going to talk about next, which is really neat, is JSONB. So if you want to use JSONB, you would need JSONP to do that. So here's an example. It's just selecting a JSON column from the employee table and gets it back as a JSON object. This is the standard JSON object. And then you could do getters on Smith. And they would be in place just as efficient as if it was an Oracle JSON object. So next we're going to talk about B, JSONB. So the B is for binding. It's another quote unquote standard interface in Java EE, now Jakarta. So this is a way to take your plain old Java objects, your POJOs. So any Java object that you're using in your app, sometimes referred to as domain objects, and you can take those domain objects and convert them to and from JSON. And the default implementation of the JSONB is called JSON. And we've worked with the JSON team. Again, they're at Oracle as well. And they've made some adjustments for us. And basically, the net effect is that you can have your domain objects, your plain old JSON objects, and you can convert them to Oson binary and persist them in the database. And then from Oson binary, you can go back to your domain objects without ever incurring the cost of parsing or materializing JSON text, because that stuff tends to be expensive. And then once these domain objects are in the database, they can be queried very efficiently. So this is kind of, you might be thinking, oh, it's kind of like ORM tools like JPA or something like that. It is, but the difference here is like there's less impedance mismatch between JSON than there is with relational. So like if you imagine you had like a domain object representing like a customer with orders, if you were using an ORM tool, that would probably map to two tables in the background. And so you'd have an order record and multiple, or you'd have a customer record and multiple order records. And when you decide, hey, I want to get this customer, it would go out and do a join between those two tables, piece it back together, and give you your object back. In the case of JSON, that can be stored as one value, one JSON object with a nested array and other JSON objects. So it's kind of a more efficient way, more direct way to model your domain objects in the database. And so here's a quick example, and there's some more in that GitHub repository I showed you. There's a more complete runnable example. Like if you have some class named emp that you use to represent your employee, you get the JSONB handle here. Then you select the JSON column from the table, and then you get it back as an event stream, a binary event stream, and then you send that to JSON, and JSON will automatically create this employee class for you. It's very neat. It's a very, very powerful feature. So I'm going to end this talk. We're about out of time with some performance tips and some performance results. So you could probably fill an entire slide deck with information on performance, but this slide here kind of has my top 5 things when you're working with Java and JSON type on how to make your program perform well. So the first thing is this Oracle JSON factory instance. Try and reuse them. Don't create a new one with every request to your app. You could, if you want to create one global one, that's fine. They're thread safe, and there isn't a lot of lock contention that would happen there. You know, I think I've seen that you get marginally better performance if you have thread local instances, but just don't create a new one with every request. And the reason is that especially when you're converting to Oson, there's internal pools here that work with memory in a very specialized way, and it kind of defeats that mechanism if you don't allow it to reuse memory across requests. Avoid JSON text. If you don't need to represent your JSON as a JSON text string, don't. Even if you're using the fastest JSON parser in the world, you know, it still tends to be expensive to create JSON text or parse it. We talked about this a little earlier, when you're calling set object, tell us that it's JSON, because the JDBC driver can know that it needs to encode it before it sends it to the server, and you'll get some compression sometimes. And then use UCP. Creating new JDBC connections in general just tends to be relatively expensive. And you know, they're technically thread safe. Like, you could in theory have all your threads accessing a single connection, but it's just not efficient to do that. You know, underneath the covers in JDBC, there's a single socket. So you want the threads as they run to have a dedicated connection that they return to the pool when they're done. And turn on statement caching. This is just a setting. It's easy. You turn it on. But every time you do prepared statement, if it has to compile that query, then that can be kind of expensive. So there's just this setting. It's off by default, but you can turn it on. It's easy, and it makes it so if you give it the same SQL string more than once, it caches that. So we ran some performance experiments. I'm just going to go over these quickly. These are just run on a normal compute node in our cloud. These are mostly customer data sets. I can't tell you what they are, but I just gave them unique codes here. And they range from, this column here shows the UTF-8 encoded white space stripped text. So it goes all the way from 613 bytes all the way up to 42 megabytes. And here's the corresponding Oson. So as these sizes get kind of bigger, we see that the values tend to be compressed. And so here's, like, if you're just reading the document and looking at every value as a tree model in your code, this shows the throughput, how many you can do per second, comparing JSON text versus Oson. If you picture the text implementation, it would have to parse the JSON and create a tree model and then iterate it. The Oson, it's just calling those get methods that we saw. So for the smaller documents, it's kind of a wash, but it doesn't hurt anything. But as you get bigger, you kind of get to see some meaningful differences. You can read twice as many documents, or in some cases, or in the case of the big document that compresses a lot, you can read 5 times as many documents. Here's the same example, but here it's kind of showing the low latency aspect of it. So if this is just doing a single path evaluation on the client side, so it gets the tree model and then it accesses a path through the document, but it doesn't look at all the values. So we get another little bump here. So now these numbers have gone up a little bit. Here it was like 5 before on the last slide. Now it's closer to 8. And this is because a text implementation would have to, convert the whole values to some other format before it could, access any of the data. But with Oson, it can jump straight to the data. Here's inserts. Again, for smaller documents, it's a wash, but as the documents get bigger, converting to Oson actually helps you, even though you're doing some more processing on the client to make that happen. It helps you because it tends to compress the document. This is the EYCSB benchmark, I think was created by Couchbase, but it's kind of a standard query, not standard, but it's a known benchmark for doing queries over JSON documents. This is comparing the response time, how fast a query comes back of text on the server to Oson. And it's a big win across the board there because the server can access these values very efficiently. Here's updates. So these are, to see the difference for updates, you have to have medium to large size documents. But this is showing the partial, if you did a partial update, text versus Oson. So at the storage layer, it only changes a small part of the document, whereas text has to do a full replacement at the storage layer. So for D7 and D11, you get a lot of benefit for update throughput. So that concludes my presentation. Thanks for watching. There's some links here. So the first link is to the Java docs for the Oracle SQL JSON package. That's public. There's this is Beta's blog on how to install and get the database 20.3 release. Here's the GitHub repository with the examples that I showed you. If you like these slides and you'd like to look at them again, they're also on GitHub. You can download them and look at them yourself. And there's an OTN page for like kind of general JSON stuff in Oracle database. Does anybody have any questions or comments?
I don't see any questions in the chat or in the Q&A. So if there are any questions, please type in them now. I have a question for you. So we're in the process of standardizing JSON type, I guess, as part of these standard comedies. We did the same with the SQL JSON operators, JSON value, JSON table, etc. So you have these objects, these Java objects called Oracle JSON object or Oracle JSON values. So if someone, let's say MySQL, starts to also implement that standard, and JDBC is also a standard, will they call it MySQL JSON value, or will every vendor give it their name, or is there like a super class or or like an interface that's
Yeah, so we were kind of very conscious of that issue when we designed the extensions to JDBC. So we're using these methods getObject and setObject, which are already defined in standard JDBC. And it's kind of their, at some point in the JDBC design, they realized that as all these new SQL data types came along, there was just kind of this method explosion. You'd have all these different getters for all these different data types. So it's very likely, I would say, that when JSON type makes it into ISO-SQL, it will go into JDBC and it will use these same get and set object methods that we did. And so the question then becomes, what Java types does the standard JDBC allow to be passed to those get and set object methods? And the only thing that I could imagine right now that they would allow to be standardized would be the JavaX JSON interfaces that we already support. Mm-hmm. But even that might be a little tricky because those are in Java EE, right? It's a different than JDBC is in the JRE. So it's not clear what'll happen there. At most, I think they could standardize the Java the JavaX JSON stuff. But then, yes, other database vendors would have the option of doing what we did as well and supporting their own specialized interfaces. But we support both. We support the standard interfaces and we support our specialized interfaces.
Okay, that sounds cool. So if someone learns to interact with JSON and JDBC using JSON type, then that knowledge or skill set might also apply for other products then. So it's
I would I think that I see what you're getting at. I would definitely say so.
Yeah, I mean, we obviously want to try for the Oracle database, but I think Java has a very large community, and if there is momentum on this, then obviously it's in our interest that other vendors also follow that standard and that example. Yeah. And by the way, for those that subscribe to Twitter, I will tweet out these links so you don't have to type them off the screen. Later today or tomorrow, I will send out a summary on this one, and this will also go on YouTube in a couple of days. So in case you missed some parts, or if you want to listen to it again, then I'll tweet the link. Yes, thanks a lot, Josh. This was a lot, very informative.
Yeah, thank you. Yeah, it's nice. This has been in the works for a couple of years, and this is the first opportunity that I've gotten to talk about it publicly. So I'm very happy to be able to do this.
Cool. And yes, if you want other topics, different topics, just tweet or contact us, and we can see what we can do presenting JSON and related technology. So just contact us, and we're very happy to provide you with the information that helps you. Okay, thanks a lot.
All right, thanks. Bye. Talk to you later.
Bye.